My name is John Luther. I'm the product manager for WebM project. With me is Matt Frost, business product manager for WebM. And what we want to do today is sort of give you an update on where WebM is and where it's come since Spring Media West 2010, where we also did a session. We also, just being at the show yesterday and today, we've also added some things just to address some of the stuff that we've heard and clarify some things that seem to need clarifying. So at the end, we want your questions and feedback, so hopefully we'll make it through this at a good clip. So just what we're going to cover, just for those of you who might be new to what WebM is, I'll just very briefly go over exactly what it is. The reasons we think everybody should use it. Just a very brief kind of survey of the browser share now that WebM has, which is they support in the HTML5 video tag natively in browsers as well as plugins for browsers. Sort of the progress that we've made with the VP8 codec, specifically the encoder, decoder since last year. Some new features that we're working on with VP8. Matt will talk about the WebM ecosystem, which includes hardware, silicon deployments that are coming in the next couple years, partners, that sort of thing. And then Matt will also give a YouTube case study about WebM. So first, what WebM is it's essentially three things. It's the VP8 video codec, which Google acquired from Onto Technologies. That's where Matt and I both came from. Open sourced it in May 2010. It also uses the Vorbis audio codec, which is a high quality, open source, royalty-free audio codec. And this is all done in a Metroska-based file container, which we chose to rename, well, not rename, but we use a different file extension for a number of reasons, primarily just to avoid confusion between Metroska files that don't have VP8 and Vorbis and those that do. So we made it a MIME type and a file extension of .webm for WebM files. And as I said, we launched it in May 2010, so it's been 18 months, something like that. So first I wanted to, if I can figure out how to get my browser back. Why don't we just do this in VLC instead of YouTube, because, sorry. It's a little video that we've made that is a WebM video, in fact. I didn't know what the bandwidth would be like. This is on YouTube, but I wanted to make sure it worked locally. So sit back, relax, enjoy the WebM video. Can you hear that? Probably
Video
not.
has been on the web since the internet was first created, and codecs have been around for decades.
Hold on a second.
Do you want to pause it?
Yeah, pause.
We created WebM because
See if this works. I lost my cursor. There we go.
Optimized for the internet and for the way users watch videos on the web today.
Is that too loud? How's that? Okay. I don't want to try
Video
full
has been
screen.
on the web
'cause I'll break
since the
something.
internet was first created, and codecs have been around for decades. So why do we need another video codec now? We created WebM because we realized the web needs a video codec specifically optimized for the internet and for the way users watch videos on the web today. Codec development emerged in the late 1980s, primarily for teleconferencing and broadcast television. As video became popular on the web in the 1990s, engineers simply applied the existing technologies to the web. After all, a screen is a screen, right? Well, not always. Broadcast television is just that, a broadcast. The stream of frames is cast far and wide over the air or cable. If you want to watch, you simply tune in to the stream and view it. The broadcaster only has to send one stream for everybody. The web is different because it's a unicast system. To watch a web video, you request the video from a server. As it's impractical for a website to continuously broadcast every video in its catalog on the chance that a few people might want to watch it. The server responds by sending you your very own stream, straight to your browser. So if 1,000 people request a video, the server has to send and manage 1,000 streams. And unlike watching video on a television set, web video must adapt to the different conditions of each user, such as, for example, the video player software, browser, screen resolution, and internet connection speed. These are only a few of the reasons why web video is different from conventional television, and why the web needs technology that was designed for these unique requirements. And that's the goal of the WebM project, to create the best video technologies for the web. Sound cool? Well, our project is 100% open source, so get involved.
Good. Is it something your grandmother would does it pass the grandmother test to explain why we're doing WebM? So that kind of sums up our thinking about WebM. It's what we are trying to do is something specifically for the internet, designed for the internet, taking advantage of the internet's capabilities, but also trying to work around its limitations for video. So at a high level, what we're trying to do is focus on simplicity of design. There's a lot of video technology that today, as the little demo video said, was not designed for the internet. It was designed for television, for CD, DVR, DVD players. So part of that we believe is low complexity decoding, which the VP8 codec features. It was designed to be very low complexity. So VP8, in general terms, a VP8 bit stream is about as complicated to decode in software, just as a reference, as 264 baseline. It doesn't have things like B frames and very complicated entropy encoding and things like that. So the other goal we have is that you should be able to serve a single bit stream to any device. No profiles. You're not going to have to create baseline for this device and main for that device and high for that. It just gets way too confusing. Levels, we believe, are useful as a reference, particularly for hardware vendors, but they also complicate things. If you look at a spec sheet for a device and it says H.264 main profile level 3.1, it's just way too complicated. B frames, IDR frames, all those things that most people don't really, they're hard to have a grasp of. They're very hard to understand exactly what they're doing. So in short, you shouldn't need a consultant or somebody to, you should have to pay somebody to explain to you how to encode videos or to do it for you. You should be able to just have an input file, output destination, click run, and not have to configure a bazillion settings. Our encoder tries to do a lot of that for you. Related to that, any compliant VP8 decoder will decode any VP8 bit stream. There's no distinction between a baseline profile, a main profile, those things. We use a single container and a single MIME type for these videos, so you don't get stuck in the, I was in Jan Ozer's session yesterday, and he talked about having .mov will launch QuickTime Player versus MP4 will open in the browser. We have one file extension, we always will have one file extension, and that's it. We don't have distinctions of things like transport versus program streams. You don't have to set a fast start bit to, I don't know if you've ever encoded a piece of 4 file that says enable fast start, all that sort of stuff. You just run the encoder, you get a WebM file, and you serve it. We also are seeing a pretty rapid deployment and growth in the number of browsers on the web that people are using that support WebM natively. We also have plugins for some of the browsers, but the native support is growing very quickly. So about profiles, I wanted to just touch on this very closely because I've heard a lot of stuff over my career, but also during this conference, is that the H.264 is referred to as a codec, but it's not. It's many. It's especially the main, the main profiles that are used are the most popular, baseline, main, and high. A high profile 264 decoder will not decode a baseline bit stream. That you have a decoder that it might have all 3 of those decoders in it. So in reality, 264 is 3 codecs. And you know this when you have to actually deploy content in the real world and you have to serve a baseline profile to this device, but then a main profile to, say, an iPad, and then the iPad 2 is released that now supports high profile. Now you have to encode high profile. So what we keep hearing is, well, WebM, I'm going to have to re-encode my whole catalog into WebM, but you're going to have to encode one WebM file, different resolutions and bit rates, of course, but you're not going to need those resolution and bit rates in each profile at different levels, so it doesn't have that same multiplicity of all of a sudden you have this enormous growing tree of files with all these profiles for all these devices. So any VP8 bit stream will be decoded and played by any compliant VP8 decoder. That's just the way we designed it, and that's the way it works. The same can't be said for 264. So just more kind of succinctly the goals. There are two essential problems that our project tries to focus on and solve. First, I've mentioned probably exhaustively, we don't believe that the technology in use today was designed for the internet. It was sort of applied there when there was no other better alternative. We're trying to define and design better alternatives. And the licensing problem. There's no high quality video format that can be used on the internet other than WebM and Augtheor that doesn't require you paying royalties to somebody. The rest of the web stack, pretty much anything in HTML, CSS, JavaScript, you don't have to pay royalties. You don't have to pay royalties to anybody to use TCP. You don't have to pay royalties to anybody to use anything in the stack except media formats, video and audio specifically. 264 and AAC require royalties. Yesterday in a session I heard somebody say that the royalty cap is $5 million a year. That's not true anymore. During the last 264 licensing period, they increased to $6.5 million a year. So that's, for large companies, obviously, like Google, where I work, that's probably not seen as a big deal, but for somebody like, I don't know, a smaller content provider, that is a big deal. $6.5 million, or a device maker, or anybody, that's a lot of money. So the specific problems that I've mentioned, but I just wanted to mention again, just to drive it home, flexibility and scalability of the bit stream. What the longer term goal that we're trying to get to is one bit stream, you encode it, you serve it, it will play on any device, any resolution. The decoder and the encoder will figure it out. You don't have to say, okay, I need a 320 by 240, 30 kilobit for this use case, and then I'm going to have it. You just encode it, put the file in the server, and let the technology figure everything else out. Adaptive streaming solutions that we've seen are kind of clumsy. The licensing terms are not very clear. We're kind of hopeful about Dash. There's still some licensing uncertainty there, but we're optimistic that that'll get worked out. Starting and seeking are pretty painful, even on very well-run websites. Seeking through a very long video file, a lot of times it just takes way too long, especially on things like devices. If you watch Netflix on a TiVo, for example, it just is extremely painful to work your way through that file. And the use of network heuristics and just the capabilities of the local device, it's all pretty dumb today. It's just, you serve the file and the client starts playing and it doesn't really do anything intelligent. We believe there's a lot more room for innovation on the client side to do smart things to figure out how to deliver the best experience to the user without the content provider having to bend over backwards and develop hacks and workarounds to do all those things. So getting to browsers, these numbers, you can't see these are from StatCounter. And these are from mid-October. I didn't have a chance to update it before I came out here, but if you look at all PC browsers worldwide, break it down by versions and then break out versions that support WebM natively in the video tag, this is how it breaks out. 45% of them, this is Firefox 4 and later, Chrome 7 and later, Opera 10.60 and later. It's 45% of browsers in use on the web as of October 2011. 43% of those browsers don't have WebM, and that includes things like IE8 and 7, which don't even support HTML5. Firefox 3.6 and earlier. 3.6 supported the video tagging only with Fiora, and the implementation was a little bit shaky. So what we're seeing is the rate of replacement on those older browsers is accelerating. Chrome, Firefox now have auto-update features where as soon as a new version is out, you're updated without even essentially knowing it. It just sort of happens. And we've also I couldn't, I tried, but I couldn't convince people at Google to give me the numbers from our own properties and statistics that we gather, but I can just tell you that those numbers back up these numbers. So 2 sources of evaluating browser share basically gave me about the same result. When you narrow it to browsers that support the video tag, which are Firefox, Chrome, Opera, Safari, and IE9, it looks more like this. 89% of those browsers have native WebM support. There's another 9% that you can install a plugin. We have a Windows Media Framework plugin that we developed with Microsoft for IE9, and we have QuickTime components for Safari. And then the other 2 are just 2% that we just can't get to, which is specifically Safari earlier than 5.1 because there was a bug in those earlier versions that wouldn't detect our MIME type or didn't allow for detection of MIME types. Can't type, it just always assumed 264. So that was fixed, and now we can get to 5.1 later, but that 2% still remains. So what we've done since last year, we've released 3 and more SDK releases. Those are named releases. We name them all after ducks, if you pay attention to our SDK releases. And you should definitely, those are worth upgrading to. I know that we have a pretty fast rate of release because we've been doing so many improvements. I'm thinking of maybe slowing that down a little bit to every 6 months for named releases instead of every 3. It's open source. You can pull from the trunk at any time and build the head of the trunk if you're adventurous and want to do that. And it is pretty stable at this point. But the named releases are definitely the ones that have had more thorough testing. So the decoder and encoder are both significantly faster. The encoder about 4 times faster than last year at this time. The decoder was pretty fast when we launched, but we increased that by about another 45%. And image quality in the encoder has improved a lot. We do a lot of objective testing, which has its critics, but it is helpful to have things like PSNR tests and SN tests to at least show, like, yeah, we're getting better. But we also do a lot of subjective human being testing where we have A and B videos and people who aren't experts in video will say, that one to me looks better, or that one to me looks better. We also have some tools that we're going to open source to measure things like jitter in the video and just general playback problems that the human eye sees, but the objective measurements available today don't really account for. Deployments. YouTube has encoded the entire catalog, video catalog into WebM for HTML5 delivery. Every new video that comes into YouTube is encoded into WebM as well as the other formats. And Matt will talk a little bit more about this when he gets to the case study later. Skype 5.5 uses VP8 video for the video calls. WebM plugins that I mentioned that we've made for IE9 Safari, Kindle Fire, which is coming out I think this week or next, supports VP8, and Google Promoting, which is now in beta, came out a few weeks ago. It's kind of like a Citrix in the browser, I guess you'd call it. You can do remote. Someone can share their desktop and you can connect to that desktop through Chrome and control their computer essentially. That uses VP8 for the video compression between the 2 machines. The libvpx Cayuga, which is the last named release we did, which was July, is an Android ice cream sandwich. That SDK has very significant performance improvements for our Neon processors, which is sort of most Android devices at this stage. And then we've filed some documents. There's an information RFC that we published with the IETF. A lot of people when we launched said you have this spec. It's not so great. And what happens if the WebM project goes away or for nuclear war happens and then I can't get to your web? So they requested what's called a stable reference for our spec. So we improved the spec. We rewrote large parts of it. We cleaned it up a lot and put it through the informational RFC process. So there's an editor at the IETF that very exhaustively goes through the document, and you go back and forth. There's a technical reviewer. This is not a standards track RFC, so we are not requesting that VP8 be standardized through IETF. We just requested that the document be published as a stable reference. There's also a project underway at the IETF and W3C called RTC Web. This is for real-time communications in the browser, so you can do, say, a video conferencing if you're familiar with Google+, Hangouts, that sort of thing. It will be done purely in the browser stack without needing plugins. So that is in process, and what we've done is we've recommended or proposed VP8 as being sort of the mandatory codec that all RTC implementations have to support as a common baseline for interoperability. We're not saying that's the only one, we're just saying it would be very useful if there was a really good high-quality codec, which VP8 was partially designed for real-time applications, and that no one had to pay royalties for it, in order to have that as the one that everybody could use and not have to pay for, so there's no barriers to using it. So that's all in process in the IETF. There's a kind of companion group in a W3C working on the kind of browser parts of it. IETF is more the protocol parts of it. So this is just a chart of how much faster the encoder is from when we launched. There's a lot of, you can see there's a lot of spikes and peaks, and then around July we really started to just get more consistent about the, how much better it got without regressions. You can see like back in December we had some weird bugs that got introduced and regressed things, but it's now definitely leveling out. This is real-time mode. That huge spike in the middle is an anomaly due to, it's too long and boring to get into, but that's an anomaly. And you can see there was still an improvement. It just wasn't, 125 or whatever percent. We were very excited, and then we discovered that it just wasn't true. It was more like, 20. There's a big jump here, you can see. And that's also, now stabilized. Still getting better, but not as radically as it was before. And this is a decoder improvement. There's also, we were pretty excited that the FFmpeg project developed their own VP8 decoder called FFVP8. It's very good. It's very fast. It's so fast, actually, that we now use it in Chrome. We have replaced libVPX in Chrome with FFVP8 because it's better. Faster, and that's the whole reason this project was started. We're not territorial about it. Someone wants to make a really great VP8 encoder, we're all for it. I encourage you to do it if any of you have that passion in your soul. This is libVPX, which we are going to use for things like real-time Hangouts, things like that, because the FFVP8 is only a decoder; it doesn't encode as well. So, some interesting new stuff that we've worked on. I've added error concealment in VP8 for real-time applications. This greatly improves the experience for the user. What it does is, essentially if you're losing packets or there's just general problems where you're not getting all the data you should to construct an image, we can conceal those errors. I'll show you, I don't want to take too much time away from Matt, so at the end, I'll play a video showing just how much better the experience is with error concealment turned on versus not. And that was introduced in our last SDK, which was Cayuga. Next thing that is one of the things we're more excited about is fast motion estimation. This is an encoding technique that we've developed that the most expensive step of encoding VP8 is the motion vector search. So what it does is it reuses what you essentially only have to do the motion vector search once. You do it in the lowest. If you're downsampling the smallest video, you encode the smallest resolution, which is going to be the fastest. You then take those motion vectors and apply them to the larger resolutions that you're encoding. So you can run 3 encodes at 3 rates, 2 different resolutions, and cut 30% off the time it takes to produce all 3 of those. So for use cases like adaptive streaming, where you want to output 3 bit rates and resolutions of the file at one time. You don't have to wait for, it's just silly to run motion searching on each one of them every single time. It's just a waste. So it's also good for video conferencing as, you know, bandwidth fluctuates. You can be encoding 3 streams at the same time and switch between them in the video conference or 2 or whatever, but you're not using as much processor to encode those images. Also something that we call lag 2-pass encoding, which takes advantage of, you know, most machines now are coming with multi-core processors, particularly servers where a lot of video encoding is done. So what we've done is developed a way to encode, you know, everyone's probably familiar with 2-pass encoding. You run a very fast first pass to gather statistics about the video and where the hard sections might be and different characteristics. And you go back and you apply those statistics in the second pass. And it creates a much better output because you sort of know things in advance as you're doing the second pass and can anticipate them. So what this does is it runs the first pass on one core and then the second pass on another core, and you can the distance, so to speak, between those 2 passes can be anything from 1 second to 10 seconds. It's configurable, but it essentially it drastically cuts down the amount of time for 2-pass encoding by just taking advantage of, well, you have 2 processors there, you might as well use them both and not just brute force, try to use as much of them as you can. Do it in a smart way, lag it a little bit, and you get huge gains in performance. So for the future, we have an experimental branch in our code repository where we and other people in the community work on sort of next generation ideas that we might implement in future versions. A lot of it's highly experimental and highly unstable, but there's a lot of really interesting work that goes on there. Just 2 of the things, 8x8 block transforms. I don't know if this is very nerdy stuff. I'm sorry if it's too nerdy, but we're working on doing those smaller macro block transforms in VP8. More work on the fast motion estimation to make that even faster. And many other things. If you're interested, you can go to webmproject.org, go to the code section of our site, and then you can go to the experimental branch and read the log history and see what people have checked in. We are, as I mentioned, exploring using Dash for adaptive streaming. We've written a spec for how the Dash spec is limited to MPEG formats, so it's MPEG 2 transport stream, I believe, and the only codec that it talks about is 264 and so forth. But in the spec, there is a provision for other formats can use Dash. It's just basically a manifest format. It's nothing too complicated. So what we've done is wrote a manifest specification for how to do WebM with Dash, and are doing some tests. We did a demo of this at the Open Video Conference in September. It was pretty well received. We're writing a metadata spec for WebM for the XMP is an XML metadata specification format. That's the one that we're using to write that. So all sorts of cool metadata stuff that you want to put in a WebM file that will now be a documented specification of what the different EBML elements are and what they mean and what you can do with them and so forth. There are now VP8 extensions in OpenMax-IL, the new 1.2 spec. What this is generally applicable to hardware. The OpenMax interface, the integration layer just makes it easier to integrate codecs and things in hardware using OpenMax. There's now extensions for VP8 that are documented in the newest spec. And more research into how to measure quality, because it's very difficult. Video is a very subjective art and somewhat of a science, but the 2 people can look at the same video, and depending on their taste and preference, they can say, that one looks like crap and that one looks great, because I've even seen this. Some people interpret blockiness as sharpness, which is odd, but they do. But then other people say, well, it looks blurry, because if you're overcompensating a loop filter or something for blockiness, they say, that one looks blurry to me. Or the color looks less saturated, when you're trying to conceal errors and things. So while, like I said, the objective metrics that are used today in the industry are helpful, and they're still, very valid to use to just sort of measure over time your progress. But there definitely needs to be more focus on actually results and testing of how human beings watch the thing and what they think about it. There are ways to sort of do that in software that we're looking at by measuring things, like I said, jitteriness and skipped frames and keyframe popping, all these weird terms that we use. But what we really want to do is focus more on the actual viewing experience. And that doesn't just mean, I think the video looks good. It's like, well, what we've seen, especially at YouTube, is there's a behavior of people that they'll open like 10 tabs in a browser and try to load the same video in all 10 tabs, and the one that loads first they'll watch, which to me seems insane, but it's a valid use case because people do it. So things like that where, there's obviously, if they think it takes that long just to load the thing and watch it, there's a problem there. So that's an example of something that we want to focus on. How do we test and measure startup time? What do people perceive as a reasonable or a good startup time? Most people compare it to their TV, where they turn it on and as they flip channels, it's very quick and it shows up. Web video is not to that state yet, and we would like it to be. So Matt's going to talk now about the ecosystem. Matt?
John?
If you use my keyboard.
So I'm going to make this quick because I think there will be some questions out there about the WebM project. And I just want to breeze through what we're doing in terms of building the WebM ecosystem. When we set out with the WebM project, there were multiple goals. One was obviously, as John was talking about, it was really building a codec, more than just a codec, a video format for the web, and eliminating a lot of the complexity around encoding video, and taking the experience that the Onto team had from almost 20 years of developing video codecs, and coupling it with the experience that Google had with YouTube, and all the sort of practical day-to-day experience that comes from serving hundreds of thousands of videos on a daily basis over the web. So the key goals of the WebM project were to build a successful open source project where it wasn't only Google doing the development of the technology, but where we were really receiving meaningful help from the community, and speeding the rate of innovation in web video technology. Because, again, the YouTube team, the Google team's interest is in continuing to improve the web video experience, and not just sort of settling on a common video standard for half a decade, but continuing to push aggressively forward and improve the video experience and the quality of video over the web. We know from our experience that to allow a new format to flourish, you need a well-developed ecosystem. And the video ecosystem is much more than just the codec or the video format. It includes creation tools. Obviously, most importantly, it includes content. It includes consumption tools, like in this case, we're pushing hard on HTML5. It could be a Flash player. It could be the player on embedded devices. And then finally, and most equally important, it includes embedded support, which is support from OEMs developing consumer electronics devices, support from semiconductor manufacturers at the hardware level. So the goal ultimately is to create a well-accepted technology where this ecosystem really grows by itself without a lot of pushing on our side, where the semiconductor manufacturers recognize that WebM is an important video format and that they have to add it to their list of formats that need to be supported. The same thing holds true for the encoder developers. But ultimately, we recognize that there was a lot of work that had to be done by us initially to go out and really explain about the WebM project, talk about the promise and where we were going. And so there's some tending to the garden that has to be done by our team. We've focused in particular lately on the semiconductor industry because, unfortunately, gone are the days where all you have to worry about is distributing libvpx, something that can play back on a PC, and that's 90% of the use case. The reality is people want to be able to play video across all of their embedded devices. And this requires really robust support from the semiconductor manufacturers. So yeah, unfortunately, the development time in hardware is measured in years, not months. And one of the challenges that we face when we try to roll out a new version of WebM somewhere down the road is going to be that you can push it out in a new library, which gets updated quite quickly across the browsers. Unfortunately, it takes, at the very sort of shortest time, probably a year before you can come out with full hardware support. And in reality, that could be anywhere from a year and a half to 3 years. But unfortunately, even though VP8, the WebM codec, is a very, it's a comparatively low complexity technology considering how much it's being asked to do, and can run back and play back in software quite easily. The reality is that people are, operating in a plug-free environment where they're concerned about battery life. People don't just want to do, one thing at a time. They don't just want to look at video, on its own. As John said, they tend to open, 3 tabs. One's running Flash, 2 are downloading the same video, and all of that really strains the processor. So it's important, with high resolutions, video conferencing, that you have very strong hardware support.
Can I mention one thing about that, Matt? I don't mean to.
Sure. Yep. No.
I've heard this a lot at the conference and other places where people say there's no VP8 in hardware. So that's somehow seen as this. But the hardware acceleration for video is about a lot more than decoding the bit stream. In fact, decoding the bit stream, in particular the case of VP8, is one of the lightest intensity processes in there. When you're talking about rendering in hardware, you're talking about color conversion and scaling the video and all these things that take a lot more power than decoding the bit stream. Now, that said, a 264 high-profile bit stream is a very difficult thing to decode in software. That's why it's almost mandatory that you have hardware on the device if you want to play high-profile. I've heard people at the conference recommending encoding 264 high-profile for all PCs, and that I think is a mistake. I wouldn't do that, because while newer machines might be able to do that, even a PC that's 2 years old, trying to play a 720p video in high-profile is, especially if it doesn't have a very good graphics card that can do all the other operations like scaling it, it's going to be pretty hard to, even this thing, which is designed by people who know a lot about 264. When I play 720p high profile on this machine, the fan starts spinning, the processor spikes. So it is important to have VP8 in hardware to decode the bit stream, which we're definitely working on, but all that other stuff that's in hardware there today, we can take advantage of, and we do. For example, in something like the TI, the OMAP 4 family of processors, there's a lot of hardware parts in there that offload all these other operations that we definitely take advantage of, because that's just part of the stack. Decoding the bit stream is important, and we're working very hard at getting all that in silicon, but it's important to remember that that's only one part of hardware acceleration.
Right.
So that's the end of my tirade about that.
And then also, I know, sort of getting ahead of myself, that if there's hardware available, it's useless if you're not writing software that's actually taking advantage of the hardware. And one of the frustrations is we've seen with past generations of the codec, there's been hardware available that people aren't actually accessing. So they've got a software library that they're continuing to use in an embedded environment when they could just call the hardware accelerated version. So just quickly moving ahead, we've got a team of very capable guys up in far northern Finland who are actually just, all they're doing is producing hardware designs, the sort of low-level blueprints that then get distributed to semiconductor manufacturers. And all of this is being done to speed the adoption of VP8 to the greatest extent possible. And as John said, TI's already got partial hardware support for VP8 on the OMAP 4. I think there's a lot more going on with major semiconductor companies that I can't talk about, but I think TI is a good bellwether for where the industry's going. We've given them, we've made these tools available for nothing to everybody out there. And we're on the 3rd version of our decoder, 3rd version, actually maybe as of today or the next couple of days, 4th version of our encoder, and it's been released to many dozens of partners. So next, just switching gears quickly, and John, I think we'll whiz through this so that we can take some questions.
Okay.
Just to establish that WebM is certainly up to the task. And we actually, I think, for those of you who were in the session before this, we heard sort of some very nice statements about WebM. From a quality perspective, which is something that obviously the YouTube team, which is paying an awful lot to distribute video, is very concerned about. WebM is completely on par, or in many cases exceeding H.264. We've transcoded virtually 100% of the corpus of YouTube into WebM, and everything new that's coming into YouTube is being encoded both in 264 and WebM. So this is obviously a massive deployment of WebM and WebM encoders. And what we're using is the libbpx encoders. So the same thing that's available to all of you guys is being used by the YouTube team to do this encoding. And again, so this is being done and being accessed by really a rapidly increasing group of WebM-capable browsers out there. And I think that's the end of our prepared comments. We hope that you guys have a lot of questions. We're encouraged to hear that a lot of people are encoding in WebM.
Yeah, I'm sorry if I rushed through all my slides, but I definitely wanted questions and comments at the end. It's always the most important and interesting part for me. Yeah, in the back.
I'm kind of new to video.
Is there a mic? I'm sorry. Do we have a hand mic? Thank you. Sorry, I just wanted to be able to get it on tape.
So I'm new to video decoding and encoding part of it. So you mentioned TIO map specifically for VP8 decoder with hardware acceleration or support there. Is there encoder? Is there hardware acceleration in the? Is there encoder in the hardwares as well?
There will be.
Okay.
The decode case has been slightly more important now just because of YouTube. But as John said earlier, one of the big users of VP8 presently is Skype. And when you're doing video conferencing, having hardware acceleration for an encoder is quite important. We have the designs. So this Finnish team that we have has an encoder design that's been distributed to many chip companies, and we expect to see encoder chips coming out shortly.
Are you at the liberty to say which chip companies, or?
I'm not at the liberty to say.
Okay.
A lot of big ones.
Yeah, we generally don't like to steal their thunder because we're an open source project. We don't make money from this, but they do. So they like to have press releases and product announcements.
But I would say to anyone here who's interested in this and has a specific use case and needs to talk to a vendor, if they talk to us, we can certainly talk to the vendor about letting you know about them, because obviously the vendors, semiconductor companies are in the business of selling chips, and you have to know that they're there to buy them.
We'll talk offline.
Okay, good.
Yeah. Oh, sorry.
Just a question about MPEG LA and their patent pool that they've set up for WebM. What's the latest on that, and how's that going to affect things?
We know as much as everyone here does, in terms of public statements from sort of rumors from MPEG LA. What we've always said is that Onto, the company we came from, was in the video codec business from 1992 until 2010 when we were purchased by Google. And we never got a letter from anyone. We never, there was never a whisper on any of these subjects. When Google acquired it, it sort of, I think, changes the depth of the pocket for the company. There was, a great deal of due diligence that was done. We've been in business for a long time with massive deployments with Flash and with Skype, which was just bought for $8 billion by Microsoft. So obviously, they made their statements. It's a year and a half since we launched the project. It's 3 years since we launched VP8.
And it's 6 months since they announced the formation of this thing, and they've not really said anything about it in that time that I know.
And we've announced this. It may be new to some of you, the Community Cross-License Initiative, which basically is kind of, you could view it as sort of a free pool where patent holders and non-patent holders join the Community Cross-License arrangement, and everybody who joins gives a license to their intellectual property to other members that is maybe essential to VP8 or to any of the WebM technologies, to all other members of the cross-license group. And that initiative was launched with partners like Cisco, LGE, Samsung, ST Micro, TI, so very big names. And I think that says a lot about the confidence that major players have in the technology. And when you look at where support's coming for, it's coming from from everywhere, from very big companies.
So like we have one over here and one over here, and one over here.
Yeah, hi. I'm quite pleased with some of the developments around HTML5, but at the same time, I'm a little depressed about.
You were depressed yesterday.
Come
on,
yeah.
get excited.
That's a little depressed at times, but
Okay.
I'm depressed that the cycle of innovation is going to be slowing here.
Mhm.
Back when you guys probably were just on 2, you had things like alpha channels being supported, and you had new codecs coming out every year, every 2 years, big advancements when there was a competitive sort of thing. It seems like now we're stuck with what are these innovation cycles going to be? Where's the pressure for the next generation of codecs and sort of exciting new experiential sort of things to be done?
We're certainly not planning to slow down. We put a lot of pressure on ourselves.
No,
We put a lot of, HEVC is going to be the first draft spec of HEVC, which is a successor 264 we published in February, last we heard. That puts pressure on us. But I mean, one of the important things for us is also, in On2, we generally was about 18 months between releases. This VP8 is so much bigger in scale than that, and it's a much better bit stream than anything we've ever developed in the past. So we think it's going to be viable for a pretty good stretch. So what we want to do is focus on how we can innovate around that bit stream and not change it so that then the hardware manufacturers have to go through a whole other cycle of fabbing out chips. And we can do a lot with the bit stream we have. I mean, there's stuff. Temporal scalability is a good example. I mean, reconstructing based only on partial frames from there's a lot of stuff we can do. But what we also want to do, especially for HTML5, is push the browser makers. We're doing this with Chrome, but we want to try to keep setting an example of doing the best possible video user experience in HTML5 and just keeping up the pressure. I don't know if that's a satisfactory answer to you, but
just to echo what John said, I think 2 things are: one, as a small private company, there are different pressures than there are when you're part of a large organization in an open source project. And we would launch generations of the product and really wouldn't do everything. We just didn't have the luxury of kind of doing everything we could to make improvements within a given bit stream, because we were in the business of selling licenses. It's a different, there are a different set of pressures now, and I think we have a lot more luxury to really exploit all of the capacity of each generation of the technology. But just to make it clear, one of the primary reasons that Google got onto was because there was real dissatisfaction of the rate of improvement in video compression technology. I mean, and also just dissatisfaction about everything around video. The sort of confusion around, as John said, the confusion around wrappers and, the file extensions. And so we are certainly not slowing up on the pace of innovation. We're just trying to think about what we can do to both innovate quickly while making sure that all the devices out there can support the technology, and sort of weighing everything while continuing to really rapidly improve the technology.
And it's definitely about more than us. I mean, it is open source, so that's why it is open, because we want there, and that's why we, the royalty issue is so important to us, is we want people to be able to innovate without having those barriers. That's exactly why Google open sourced it.
And as you innovate, you can just roll it out into your decoders.
Yep.
And the support will be there.
Bitstream will not change, but every other tool, every other thing we can do around it, we will definitely be making a lot of improvements and changes. I don't want to run over, but there's 2 over here.
Thank you.
I think you were first, the gentleman in the checkered shirt. Oh. We run dry. It's these lights. I feel like I've been arrested or something.
Thank you. So, yeah, a very interesting presentation, and I guess a model for open source and open standards in general, especially with respect to codecs. And if you look at WebM here, I mean, you've described containers, codecs, manifest files, all sorts of things. Have you ever thought about implementing a DRM, or even as an open source DRM, anything like that? Has that ever been considered or thought of?
Yes. This is probably my fault. I might have been flying through my own slides so fast that I didn't. Content protection comes up all the time. People ask me about it. I had it in here, but yeah, we have. I mean, there are many people who claim that a lot of things that we want to do, and a lot of what motivates us, and this sounds maybe a bit corny or hackneyed, but when people tell us stuff is impossible, then that's sort of a motivating factor. People tell me all the time, open source DRM is impossible, and it's not. I come from, I mean, I worked for RSA for 7 years. I know encryption. I know that whole. It's about managing secrets. That's all it is. And so if you can manage those secrets, and everything else in the environment, SSL has open source implementation. It's not, you know. So what we want to do, and I think you were in the Adobe session yesterday where I kind of shot my mouth off about it. The whole full-blown DRM, lock everything, is not necessary for the web, in my opinion. You look at the most popular video service in the United States, which is Netflix. They don't do DRM. They do encrypted streaming. There's a license check. There's a validation of, is this person a subscriber? Do they have the right to watch it? But there's no rights management going on there. There's no, they're protecting buffers and things to make sure people aren't ripping it up. But it isn't DRM, and that's part of the confusion. What we talk about and what we want to work towards is a same level of content protection for video served over the web. We're not as interested in local playback because the vision that we have for the web is that the networks are getting better and faster. You will be always connected. I mean, most people are today. The speeds are just not as ideal as they should be, but LTE, 4G, WiMAX, all these things are coming. So yeah, it becomes just a matter of protecting it to the level that you make the studios comfortable, which I think definitely for standard definition is definitely possible today. And then working with other browser vendors and people to make sure that the APIs are there. We're working on that too.
Right. Are you going to publish a spec with respect
Oh yeah,
to DRM?
anything we do, we publish. We don't do anything
Time frame?
in secret. I'd like to, I'd say stay tuned. It's something really important to me, and I'm pushing it pretty hard. So, yeah, I'd look for it soon, hopefully. So,
you'd talked a little about serving a single stream to then, multiple mobile up to a high def. Can you talk a little more about that and what the expectation is of how?
yeah. So let's say something like. What we do today in VPA with temporal scalability. So you can reconstruct based on only certain if you're only getting so much data of the stream, you can construct an image based on that. And there's different levels in there. So you can do like a QVGA, low bit rate, and then 480p higher bit rate. All of it is coming. It's kind of hard to envision, but it's all coming in the same
container. The same file?
Same stream.
And
the client is going to be, it doesn't even have to really be that smart, it's just how the decoder is going to.
And it does it have to receive the entire data file?
No.
Okay.
I know, it's hard to get your head around. But that's what we have today.
Is that available today in what's?
Temporal scalability, yeah, it's in VPA.
Okay.
Yeah. Go to the site, and there's or offline if you want to get my email address, I can send you a slide deck about it. The decoder just can get enough data to construct low quality image, or it's getting enough data to construct a medium quality, or if it's getting everything, it can construct the HD image.
I mean, technically, how does it? I mean, is it through a byte rate? I mean, how does it know which part of the data file to get to only? Right? I mean, when you say part of it, it's only getting part of the data. Is it the first part? Is it, I mean, because you're talking about like an HTTP request for data.
Yep, you can
So-
do a lot if you have, because in VP8 there are different types of, we don't have B frames, but we have something called an ultimate reference frame, golden frame. You can do a lot to construct images just based on if you're getting those.
Is it like partial byte range requests through different parts of the file? Or, I mean, technically, how does it?
No, I mean, the byte, this is why it's so hard to,
Because you either get, I'm just, not to drill down.
No, I know,
crazy
I know, it's
details,
hard
but-
to
But
explain
like,
it.
you know, if the first 2 minutes of the file are in the first 2 meg,
yeah.
for an HTTP request, you either get that first 2 meg, or you get portions of it, or, I mean, you either get 2 megabytes of data or you don't. From an HTTP, just, I mean,
Right, but instead of
baseline.
getting an HD keyframe, a bunch of, reconstructing HD interframes, and you're getting enough in each keyframe to construct interframes. In other words, you don't have to get a whole 2 megabytes of the whole video data stream. You can get enough in doing smaller requests to construct images with less data. This is really.
I'll take a look at what's.
I might even have the slide here. It's a graphic with all these little blocks, and it shows you how each one builds on the one under it to get to that. It's also very useful in live, like video conferencing and stuff.
Yeah, exactly.
So I do a poor job of explaining it, but it's really very technically kind of bizarre stuff.
Thank
In the back. But for the future, and what we have today, I just want to say is it's not crude, but our ideal vision is a way to do one bit stream that would do any resolution. Right now, the temporal scalability we have is limited to one resolution. We want to do multi-resolution, multi-bit rate, everything. Just do it smart enough that you just need the one stream to do any device, any bit rate, any resolution, which is a challenge, but we think we're up to it.
So sounds like what you just explained is like an answer to SVC, scalable video codec, that's like the next generation of H.264. And like, do you have, or WebM have a goal for supporting 3D videos like multi-view codec does MVC?
Yeah. I'm not your best booster of 3D. I think it's really gimmicky, and I don't see much of it for the web. Again, my job and my passion is web video. 3D is, I don't know. I've been hearing for 15 years that next year is going to be the big year for 3D. It comes in the cinema, there's been blockbuster movies, but it just never seems to, especially with the glasses, and it just, you look like a weird person sitting there with these big glasses. So until somebody figures out how to do it without the glasses in a way you just turn it on and it works, and it doesn't require special encoding or extensions, like the one you mentioned, the 264 multi-view thing, yeah, we can do it. We do it today. We do stereoscopic 3D. We did a project with Firefox and NVIDIA to do stereoscopic stuff on YouTube, but that's as far as I would like to take it for the foreseeable future. But an SVC, I mean, yeah, it's similar to that, but SVC we think is another area where 264 just has design problems. And it's an extension too, it's not part of the core spec. So anyway, that's my.
But I mean, in terms of the temporal scalability, it is analogous. I mean, you're right that it is similar
it's
to
analogous,
WebM.
yeah.
I mean, it's the same concept as SVC. I mean, they employ sort of.
Yeah. We think there are better ways to do it than SVC.
Actually, I may have missed in this presentation. Is WebM supported natively in Android?
Yes.
Yeah. Actually, and Google TV.
Yeah.
And Google TV as well. Okay.
Right.
Which version?
Ice cream. Well, it was added in 2.3, which was Blueberry Pie. The library in Ice Cream Sandwich is far superior to what was in Gingerbread and Honeycomb.
Okay.
And Google TV now is rolling out an update that is based on Ice Cream Sandwich. So we're starting to finally get all that stuff that we want in one release. Anything else? very much. Enjoy the lunch, and I hope you win an award.